There's a famous interview where Richard Feynman, one of the greatest physicists who ever lived, gets asked a seemingly simple question by a BBC reporter. Why do magnets repel each other? Feynman's response wasn't what anyone expected. He didn't launch into a brilliant explanation filled with elegant metaphors and clear reasoning. Instead, he refused to answer. Not because he didn't know, but because he understood something the interviewer didn't. The question itself was impossible to answer in the way it was being asked. Most people who watch that interview think Feynman was being difficult, maybe even arrogant. They assume he was hiding behind complexity or refusing to make physics accessible to ordinary people. But they're completely wrong about what happened in that moment. Feynman wasn't avoiding the question. He was trying to teach something far more important than magnetism. He was trying to show that our intuition about how explanation works is fundamentally broken when it comes to the deepest layers of reality. Let me show you what he meant by walking you through the same territory. Grab two magnets right now if you have them. Hold them with the north poles facing each other. You can feel it. That strange resistance pushing through nothing but air. There's an invisible barrier between those magnets, and your brain immediately wants an explanation. You want me to say that magnets repel for the same reason that something else happens, something you already understand. Maybe springs pushing back, maybe rubber bands stretching, maybe two people's hands pressing against each other. Here's the problem with that desire. There is no something else. I'm not being coy or protective of secret knowledge. I'm stating a fact about how physical reality is structured at its foundation. Magnetic forces exist at the basement level of nature. There's nothing simpler underneath them that I can point to for comparison. When you ask me to explain electromagnetism by referencing something more basic, you're asking me to do something that's logically impossible. It's like demanding I explain addition using something more fundamental than numbers themselves. Now your brain is probably pushing back. You're thinking that surely you've heard explanations before. Magnetic fields surrounding the magnets, electrons spinning inside atoms, patterns of force extending through space. Those all sound like deeper explanations, right? Wrong. Those are descriptions, not explanations. And you need to understand the crucial difference between describing something and explaining why it exists in the first place. Or this entire conversation is going to frustrate both of us. Let me demonstrate what I mean with something that seems completely unrelated. Right now, push your palm flat against your desk or table. Push hard. Feel that solid resistance. Now here's my question for you. Why doesn't your hand pass straight through the desk? What's actually stopping you? Your first instinct is probably to say the desk is solid. But think about that answer for a moment. That's not actually an explanation, is it? That's just another word for the thing you're trying to understand. You're saying the desk stops your hand because it's solid, and it's solid because it stops your hand. That's circular reasoning dressed up as an answer. Try going deeper. Maybe you say atoms are packed tightly together in the desk. Better, we're making progress. But keep pushing. Why don't the atoms in your hand pass through the atoms in the desk? Are atoms themselves solid little balls that bounce off each other like marbles? No. And this is where things get weird. Atoms are almost entirely empty space. If you scaled an atom up to the size of a sports stadium, the nucleus would be roughly the size of a marble at the center. The electrons would be tiny specks orbiting way out near the stadium walls. Everything in between is emptiness. So your hand, which is made of atoms, is essentially empty space. The desk, made of atoms, is also essentially empty space. Two clouds of emptiness pressing against each other. Why don't they pass through? Now you're starting to feel uncomfortable, and that discomfort is exactly where real understanding begins. The answer is electromagnetic repulsion between electrons. The electrons in the atoms of your hand carry a negative charge. The electrons in the atoms of the desk also carry a negative charge. Like charges repel each other. When you press down on the desk, what you're feeling is trillions upon trillions of tiny electromagnetic interactions happening at the atomic level, all adding up to create what you perceive as solidity. But here's where we hit the wall that Feynman was trying to show the BC interviewer. Why do like charges repel? Go ahead, try to answer that. You can't. Not in the way you want to. You can say it's because of the electromagnetic force, but that's just naming the phenomenon. That's not explaining anything more than saying magnets repel because of magnetic force. You're moving in circles. The electromagnetic force is one of four fundamental forces that govern everything in the universe. It's not caused by something else hiding behind it. It's not derived from some even simpler principle. It simply exists as a baseline feature of reality. And here's the part that should really mess with your head. The force that stops your hand when you push on the desk is exactly the same force that makes magnets push apart. Not similar, not analogous, identical. The electromagnetic force. So why does one situation feel obvious and natural while the other feels mysterious and weird? I'll tell you exactly why, and it has nothing to do with physics. It has everything to do with psychology. You've been pushing on solid objects since before you could walk. By the time you were a toddler, your brain had accumulated an enormous library of sensory experiences. Grabbing things, dropping things, bumping into walls, touching surfaces. Your neural pathways wired themselves around these constant interactions. You built an entire intuitive framework for understanding solid objects without ever thinking about it consciously. So now when you push on a desk, it doesn't feel like it needs explaining. It just feels normal. Your brain has categorized it as obvious. But magnets push through visible empty space. You can see the gap between them. You can slide paper through that gap. There's clearly nothing there, yet they're pushing against each other. That violates your intuitive framework. That feels wrong. That demands an explanation because it doesn't match your accumulated experience. Here's the truth that's hard to accept. The weirdness exists entirely in your perception, not in the physics. When you push on a desk, the electrons in your hand never actually touch the electrons in the desk. They repel at a distance. It's an extremely tiny distance, just a few atomic diameters, but it's still a distance. We call it contact because the gap is too small for us to detect with our senses. But contact is an illusion. Nothing is truly touching. It's electromagnetic repulsion operating across empty space. With magnets, the gap is larger, a centimeter or an inch, large enough to see clearly, large enough to trigger that sense of wrongness in your brain. But the underlying force is identical. The mechanism is the same. The only difference is scale, and that difference in scale is messing with your intuition, making you think one situation is normal and the other is mysterious. The mystery is manufactured by your expectations, not by the physics. Now maybe you're thinking quantum mechanics must provide the deeper explanation. Surely when we get down to the quantum level, we find out why electromagnetic force exists. Wrong again, and this is important. Quantum electrodynamics, the quantum theory describing electromagnetic interactions, is the most precisely tested scientific theory humans have ever created. We've measured certain predictions to 11 decimal places of accuracy, and the theory matches experiment perfectly. But here's what quantum electrodynamics actually gives us. It gives us rules for calculating electromagnetic interactions with absurd precision. It provides equations that let us predict outcomes. It offers mathematical machinery of incredible power. What it does not do and cannot do is tell you why the electromagnetic force exists in some ultimate philosophical sense. It describes how the force behaves with perfect accuracy, but it doesn't explain the force away. It doesn't reduce it to something even more fundamental, because nothing more fundamental exists. Let me show you how this pattern works with a different example. Suppose you ask me why ice floats on water. I can tell you it's because ice is less dense than liquid water. Why is it less dense? Because the crystal structure that forms when water freezes has more space between molecules. Why does that structure form? Because of how hydrogen bonds arrange themselves at freezing temperatures. Why do hydrogen bonds arrange that way? Because of quantum mechanical properties of electrons in water molecules. Why do electrons have those properties? Because of equations like the Schrödinger equation and principles like the Pauli exclusion principle. Notice what's happening at each step. I'm giving you a deeper answer, but I'm also just pushing the why back one more level. Eventually, very quickly actually, you hit bedrock. You reach the fundamental equations and basic forces. At that point, the only honest answer to why is that's what we measure. That's what the universe does. We can describe it mathematically with precision. We can test it experimentally millions of times. We can use it to build technology. But we cannot explain it in terms of something more fundamental, because nothing more fundamental exists. Every chain of explanation has to end somewhere. Here's the deep issue with asking why magnets repel. When you pose that question, you're not actually seeking information. You're seeking psychological comfort. You want me to connect this unfamiliar phenomenon to something familiar, so your brain can stop feeling confused. You're asking for a story with a narrative arc that terminates in something you already understand. But magnets repel because electromagnetic force exists. And electromagnetic force exists because that's a fundamental property of how our universe is built. There's no story behind that. There's just mathematics and measurement. I know that doesn't feel satisfying. I know you want more than that. But the universe is completely indifferent to what you want. Reality operates according to its own rules, regardless of whether those rules match your preferences for how explanation should work. Let me tell you what bothers me most about this question. People treat magnets like they're the one weird exception in a universe of normal things. That perspective is completely backwards. Everything is electromagnetic if you look carefully enough. Why do chemicals react with each other? Electromagnetic forces rearranging electrons. Why does light reflect off mirrors? Electromagnetic interaction at the surface. Why can you see colors? Electromagnetic radiation at different wavelengths hitting your retina. Why does your phone work? Electromagnetic forces pushing electrons through circuits. The electromagnetic force isn't some exotic phenomenon that only appears in magnets. It's everywhere around you, constantly. It's the dominant force in your entire existence. Gravity is weaker by a factor of 10 to the 36th power, utterly negligible at the scale of atoms and molecules. The strong and weak nuclear forces are locked inside atomic nuclei, too short range to affect anything you can touch. Everything else, and I mean literally everything in your daily experience, is electromagnetism. The force making magnets push apart is the same force holding your body together at this exact moment. The same force keeping you from falling through your chair. The same force allowing light to reflect off this screen into your eyes. So when you ask me to explain magnetic repulsion by comparing it to something normal, you're actually asking me to explain electromagnetism using electromagnetism. It's circular. It can't be done. Let me try a different angle that might help. Imagine trying to explain the color blue to someone who's been blind since birth. You can show them the sky if they could see, a blue shirt, blue paint. You give examples. But how do you actually convey blue to someone who's never experienced it? You can talk about wavelengths around 450 nanometers. You can describe where blue sits in the spectrum between green and violet. You can explain all the physics of blue light. But none of that conveys the actual experience of blueness. They would have to see it themselves. There's no shortcut. Same principle with magnets and electromagnetism. You don't gain intuition from analogies. You don't get it from a quick explanation. You build intuition by working with the mathematics, solving problems, making calculations and predictions, testing those predictions. After months or years of working deeply with electromagnetic theory, something shifts in how your brain processes it. The equations start feeling natural, even obvious. Not because they match your everyday experiences, but because you've built new everyday experience, mathematical experience, experience with how fields behave and interact. At that point, magnets aren't mysterious anymore. They're exactly what you'd expect given charged particles and electromagnetic fields. But you can't shortcut that process. You can't skip to the end where it feels intuitive without putting in the work. You have to earn that understanding. Now let me tell you what I can actually give you. The technical answer that goes as deep as possible. Magnets contain magnetic dipole moments, essentially tiny arrows of magnetism from spinning electrons. When you align huge numbers of these dipoles in the same direction, you create a permanent magnet. Those aligned dipoles produce a magnetic field configuration that contains stored energy. Physical systems naturally evolve toward lower energy states whenever possible. When two north poles face each other, the configuration has high energy. Moving them apart lowers that energy, so the system pushes them apart. That's repulsion. That's the answer. That's as deep as it goes. Want to know why dipoles create fields? I can explain about moving charges and electrons spin. Want to know why electrons have spin? I can tell you about the Dirac equation in quantum mechanics. Want to know why the Dirac equation works? I can tell you it emerges from combining special relativity with quantum mechanics. Want to know why those theories are correct? Because they match reality. Because we've tested them millions of times in millions of ways, and they work perfectly. That's where the chain ends. Not in some profound philosophical truth, but in brute empirical fact. Here's what you need to understand about how physics actually operates. We don't start with philosophy and derive the universe from pure thought. We start with measurements and observations. We notice patterns in those measurements. We write mathematical equations describing those patterns. We test those equations against new experiments we haven't done yet. When the equations work, when they successfully predict things we haven't observed yet, we say we understand the phenomenon. Understanding in physics doesn't mean achieving philosophical satisfaction or matching your intuition. It means gaining predictive power. It means being able to calculate, predict, and build technology that functions. By that standard, we understand electromagnetism better than almost anything else. Quantum electrodynamics has been tested to ridiculous precision. We can calculate the magnetic moment of an electron to 11 decimal places, and experimental measurement agrees exactly. So when I say I understand magnets, here's what I mean. I can calculate the force between any configuration of magnets. I can predict exactly how they'll behave in different arrangements. I can design electric motors, generators, and MIDI machines. I can manipulate magnetic fields to trap particles or focus particle beams. That's genuine understanding. That's what physics offers. Not comfort, not familiar stories, but power, actual control over natural phenomena. You might find this answer unsatisfying. And that's fine. The universe doesn't owe you an explanation that makes you feel comfortable. It doesn't owe you a narrative that matches your intuition about how things should work. Your intuition evolved over hundreds of thousands of years to help your ancestors survive. It evolved to throw spears, gather food, and avoid predators on the African savanna. It absolutely did not evolve to understand quantum fields or electromagnetic interactions at atomic scales. So when physics reveals something that contradicts your intuition, particles behaving like waves, time passing at different rates depending on velocity, magnets pushing through empty space, you face a choice. You can reject it as mysterious and demand better explanations that don't actually exist. Or you can expand your intuition, learn the mathematics, work through the problems, build new mental models based on equations and experiments rather than everyday experience. That's what physicists do. None of us found quantum mechanics intuitive when we first encountered it, but we worked with it long enough that it became familiar, and eventually it started feeling natural. Not because it matches common sense, but because we built new common sense around it, mathematical common sense. So here's what I want you to take away from all this. Next time you pick up two magnets and feel them push apart through empty space, don't ask why in the way you've been asking. Ask how instead. How does the force depend on distance? How strong is it compared to other forces? How can I calculate it precisely? How can I use this force to accomplish something? Those questions have answers, excellent answers, precise answers, beautiful answers. The why question, the one demanding reduction to something more familiar, doesn't have an answer. Not for magnets, not for any fundamental force. Because fundamental means exactly that, bottom level. Nothing underneath. That's what makes it fundamental. But here's what people miss when they get stuck on why. Physics reveals that the universe operates according to a remarkably small set of rules. The same equations describing magnets also describe lightning, brain signals, computer processes, auroras, chemical bonds, why stars generate light, why atoms remain stable. That's not a failure of explanation. That's unification. That's discovering that underneath all the apparent complexity and diversity of nature, there's deep structure, mathematical structure, simple rules producing incredibly complex consequences. That should blow your mind. Not that we can't reduce magnets to something simpler, but that we can reduce thousands of seemingly different phenomena to the same underlying force. You wanted me to explain magnets by comparing them to something familiar. I'm telling you something better. Everything familiar is actually electromagnetism. Different configurations, different scales, same fundamental force. Your desk, your body, the air you breathe, light itself, chemistry, life, consciousness, all of it is ultimately different arrangements of electromagnetic interactions playing out according to the same rules that make magnets push apart. You're not separate from the magnets observing some external mystery. You're made of the same force they are. So was Feynman's refusal to answer the BBC interviewer arrogant? Absolutely not. It was honest. He could have given a comfortable lie. He could have said magnets are like springs pushing back, or think of magnetic fields as rubber sheets stretching, or whatever analogy would have made the interviewer nod and feel satisfied. And the interviewer would have learned nothing of value. Instead, Feynman told the truth. The question itself was broken. The kind of why being asked doesn't exist at the fundamental level of reality. Things simply are, and our job as scientists is to describe them with precision, not to reduce them to something more psychologically comfortable. People criticize that answer, called it evasive, accused him of failing to communicate. But they were completely wrong. Sometimes the most honest answer is acknowledging that the universe doesn't work the way your intuition expects. Your expectations are wrong, shaped by limited experience. And if you genuinely want to understand what's actually happening, you need to learn a completely new way of thinking. That's not arrogance. That's showing respect. Respect for truth. Respect for the actual structure of reality. And respect for you, for your capacity to handle truth instead of requiring comfortable fiction. So pick up those magnets one more time. Feel that invisible push. Now understand what you're actually feeling. One of four fundamental forces of nature. The same force that enables chemistry. The same force that allows stars to shine. The same force holding you together at this exact moment. That's not mysterious in some negative sense. That's magnificent. And the fact that we can describe it with equations, test those equations with experiments, and use that knowledge to build technology that transforms civilization, that's not a failure to explain. That's what real understanding looks like.